Okay, let's get started. This is a big class, also a big classroom. I think I know some of you. I've seen some of you in my software security class, but I see you. There are several of you took my software security class. Okay, so my name is Zeming Zhao. I'm an assistant professor in this department. So this course is computer security. It's 4-term 565. So we have undergraduates, graduate students. So any undergraduate here took 365 introduction to computer security before? Okay, 1, 2 there, or maybe just 1. Oh, several, 3, 4. So if you already took 365, I'm not sure you will get much from this course because there is a lot of overlapping between those two courses. So this course is mainly designed for undergraduates who didn't take 365 or graduate students come from a different background, never had a security class before. So you can try the first 2 weeks, and if you feel there is really not much to learn, maybe you can consider drop this class. Okay, first off, academic integrity. So for all of you, your first assignment before we talk about any technical things is to get yourself familiar with the UB and also our department's academic integrity policies. We already put a quiz on the UB Nurse website, and everyone has to finish that in the first 2 weeks, but you don't really get any point for doing that. But if you don't do that, you cannot pass the class. I list several examples here for you to consider, but we're not going to go through each of them. So for AI, there are university level policy, college level policy, and also department policy. You need to get familiar with all of them. In short, plagiarism or any form of cheating in homework exam is subject to some serious penalty. And I have failed students for AI reasons before. And if you are caught, I will report this to the dean's office. So this is serious, especially when we have a big class like this. All the classes are recorded, so I asked the IT to schedule automatic recording. So I don't know if it's on or not. So for the first class, they will tell me later. If it's not working, then I'll make sure it works Wednesday. So usually I record all my classes and I put them just on YouTube. So it's easier for you to access. You don't need to log in, just YouTube. But I also require you to attend all the classes in person. There will be one attendance check each week. We have 2 classes each week. There will be one attendance check. I will not tell you which day we will do that. Well, obviously today I didn't bring anything, so you know when will be the attendance check this week. So I put everything, not really everything. So in this class, I put the lecture notes video on my website. So, but the homework will not be on the website. The homework will only be on UB Nurse. I do teach other classes, and which I put everything on the website. And feel free to interrupt me, ask any questions during the class. A little bit about myself and what I do. My name is Zeming Zhao. I am an assistant professor here. I direct my own lab, cyberspace security and the forensics lab, or I call it cacti lab. So I also have a hacking group. So if you are interested in hacking, you are also welcome to our hacking sessions. We do hacking training every Friday, 3 to 5. We do all kinds of battery hacking, web hacking, those stuff. That's open to everyone, and you can come and go. We play CTFs together. So the best way to reach me is Slack. The TA already invite all of you to our Slack channel, and also shoot me an email. I usually reply you really quick. My office hour will be 2:30 to 3:30 before this class Monday, and also you can join my office hour. I will also log in Zoom there, so you can join remotely. Or my office is in Davis Hall. The TA also has an office hour. Oh, there's a typo. It's also 2:30 to 3:30 on Wednesday. Anyway, if you have questions, ping us on Slack. We can also schedule ad hoc meetings, or just show up in my office. If I'm there, I will be happy to help you guys. So this is my Slack channel. I have all my classes recordings there. Usually I teach software security. I don't really teach this class in particular. This one is computer security. This is an introduction course to all kinds of security problems, the fundamental principles behind all security problems. Usually I teach software security, which is a more focused course on binary hacking. So some of you took that course with me. I also teach advanced software security, but I do not offer that very often here at UB. I only offer that to people who took my software security course. So in the software security course, you get your hands dirty, you hack all kinds of challenges I designed for you. In advanced software security, we'll talk about how we can automatically hack those challenges. How do we automatically find those bugs? I also teach network security before, but I'm not offering that at UB. But all of those videos you can find on my YouTube channel. So for this course, the same thing. I will put everything on YouTube. So a little bit about my research, why I teach computer security or cybersecurity. So my lab, we work on all kinds of cybersecurity problems, but our focus is software and system security, especially for low-end devices. We do work on other traditional desktop, laptop system, but right now we are focusing on low-end devices. I don't know if you heard a CPU called Cortex-M CPU. So that is actually a very, very popular CPU. I believe some reports said there are 200 billion Cortex-M CPUs deployed in the world. They're just very tiny microcontrollers without an MMU. So your phone may come with several Cortex-M microcontrollers. It has a main CPU, which is a Cortex-A CPU. It may also have several Cortex-M CPUs. So right now in my lab, we are very into the security of those kind of low-end systems because the hardware layer, they do not provide a lot of security features we're already very familiar with, like memory management, so unit. So we are thinking about without those hardware features, how can we provide the same level of security? We do a little bit machine learning security. We use a lot of machine learning in our research. We do not claim ourselves as machine learning guys. We do not advance machine learning, but we do use machine learning for security. We also do some machine learning, explainable machine learning, especially when machine learning is applied in intrusion detection system in other security domains. A lot, autonomous driving security, formal methods to formally verify code, and also formally verify crypto protocols, blockchain security, and a lot of hacking. We do a lot of hacking, binary level, web security also. So for those who took my software security course, you know that we have a hacking platform. The platform is an open source one. We developed on top of the open source one, and a lot of features there. And there are maybe over 100 challenges there for now. And I designed all the challenges one by one. The platform is actually open to everyone. I mean, even if you are not in the course, you can access our platform as long as you are on UB campus. We're trying to make it public, but we are not there yet. So if you are interested in all kinds of research in security, you can contact me. We can say if we can find a project for you. You can do for credit, do independent study or volunteer research, or even funding research. I always look for PhD students. Okay, so we have a huge class here. This is probably the biggest class I taught at UB. Maybe 100 people, I believe, or 90 something. So this is the biggest I have at UB. Usually my software security class start with 70, 60 people, something like that. Then when the semester ends, there will be 38, 40 people, usually like that. Okay, so this one is easier. So I guess more people will stay here. So that one is very heavy. Every week you will do hacking with me. So there are several PhD students here. Most of you are master students, some undergraduates. Like I said, if you already took 365, probably there is a lot of overlapping. Okay, I talked with Alan, who teaches 365. We both feel there's a lot of overlapping. So, but still, it's your call. You think if you can really still learn something from this course. Okay. So all of you, you should already get the invitation to join the Cacti workspace. That's a Slack channel. So usually I'm very responsive there. If you ping me there, I usually get back to you in minutes. And also, we have CTF channels inside that Slack channel. So if you're into CTF, everything, you can also look around. So this class, like I said, this is a class for fundamental principles of security. It's not a focused course. So in this course, we teach you the basic knowledge, and also tools, mechanisms to safeguard our computer and the communication system. So we will cover a lot of topics. For example, we will cover cryptographic background and tools. I don't believe we have a crypto class in our department, so this is probably the course if you want to learn how to use crypto. So the crypto part, we will go deeper than 365, but still, I do not claim myself a crypto guy. Actually, my master's degree was in cryptography, but I never claim myself to be a crypto guy. Crypto is much different from security. I'm more like a system security guy. We use crypto as a tool to secure our system, but to advance crypto, I feel I do not have the ability to do that. We cover basic access control models, authentication. Those two concepts are highly related to each other, but they are different concepts. Everyone uses authentication all the time. Your phone, you have a fingerprint there. You use a PIN to unlock your phone. That's authentication, right? And when you use your Windows or Linux system, whether you can access a file, that is access control mechanisms behind that. We talk about software security in this course, but it will not be as in-depth as my software security course. We also talk about network security and internet security. Those are basically systems you use every day, the internet security. You have been protected by those systems without knowing they exist for most of you. Then for large enterprise networks, we have intrusion detection system, intrusion prevention systems, firewalls, those kind of systems. Everyone is protected by those systems. So we will study those systems, the principle behind them. We will look at some concrete examples, and there will also be some hands-on assignment for you to set up those systems. Database security, privacy, identity management. Also, we will touch about legal and ethical parts as well. sometimes they motivate us to do security. So while we are covering so many topics in one course, because of this course cannot go very deep like a focused course. But because to me, that's because computer security right now is really, really broad. It's not like 40 years ago, 50 years ago, there could be a leading researcher in cybersecurity, or that time no one used the word cybersecurity, in computer security. A leading expert knows everything about security. Right now, I do not feel there is a single guy can claim that can claim he knows everything about security. There are just too many areas. Network security itself is a big area. Maybe even most people, when they think about network security, will also think about web security, but they are much different things, right? Because web security is only at the application layer of the whole network stack, and we know that network has 4 layers or 7 layers, depends on what kind of models you are using. Then software security is a huge area. So in my course of software security, I only cover binary part. Then like a web security, technically it's also software security. So the web system you are running, the browser plays the role of an operating system. On top of the browser, you run JavaScript or other code download from the internet. So the browser is kind of like an operating system. Then the code you're running there, then you can do all kinds of program analysis. So that also becomes a software security problem. Then when I talk about system security, usually we talk about, because the word system is also overloaded. Everything is a system, right? But when I say system security, I'm mainly talking about the operating system layer. So how do we change our operating system to make your system more secure, and even to protect your applications, and users do not need to know how those are implemented. And also safety issues in programming languages. That is also a very hot area. How many of you heard about the new, well, it's not really that new anymore. There's a programming language called Rust. Yeah, many of you heard about Rust. So Rust is supposed to be a next popular language to replace C and C++, right? So Rust obviously embodies a lot of research in secure programming language design, decades of research in that. Then there is database security or data security. So if you think about the history of security, if you think about 100 years ago, before there is computer, or maybe 150, 200 years ago, before there is computer, then what is security about? Security is about data security. It's all about data security. It's about if someone can access your data, someone can intercept your communication, right? So crypto is kind of like the very first area of security at that time. The crypto has been there for thousands of years. But now data security have new meanings, also database security. Then we have usable security. So there are a lot of systems, they can be very, very secure, but the cost is very, very high. No one wants to use it, right? So each one of you are using some security mechanisms every day, many, many times, right? You unlock your computer, you unlock your phone. So one of the security mechanisms you use a lot is a password system, an authentication system. But how many of you are really using a strong password system? How do you know it's strong? Yes. So then several years ago, like 10 years ago, people figure out maybe the best way for authentication password system is to just use a password manager on your browser, right? So it makes it much more usable. You only need to remember one password, and under that one password, you can have different passwords for different websites, and each of them is randomly generated very long enough, right? But still, there are many people not using those kind of tools, even though we feel those tools are already very easy to use. If you talk with your parents, if you talk with your grandparents, you will be surprised how simple their password is, right? So how do we make the security usable, especially for non-technology people? That's also a great research area. Access control models, we'll talk about that. And privacy is getting more and more important. Also, cybercrime. So for cybercrime, not only computer science people are studying that, also researchers from criminal justice, researchers from business school, they want to know those cybercrime groups, their organizational structure, how do they monetize things, what are they really getting from those kind of illegal activities. So I always have a picture like this for my classes to show you where this course is at in a bigger picture if you want to be a security guy or security researcher. So in our department, we offer 365, Introduction to Cybersecurity, and this course, a lot of overlapping, like I said. Then there are other, I would say, very important courses for you to understand security, like 220, system programming, operating systems, compiler. Those courses are critical if you really want to understand security, understand how system works. I know most of the people right now, they only want to study AI. They only want to study application layer. But usually high-level stuff will be easier to study. Even you can do that by yourself. But how many of you feel you can do operating system and compiler just by yourself? It's very difficult, right? So I would suggest everyone to take those courses when you still have a chance. So then after taking this course or 365, I feel you can go to, if you want to do security, then you can take some focused security course. For example, the software security course I offer here. Also, we have a network security course. We used to have a web security course as well. So those are very focused. Web security course, we're only talking about web server, we're talking about browser, talking about different attacks there. Software security is just binary. Network security talk about how do you do attacks and defense at each layer of the network system. If you want to be a software security guy, then you can take my advanced software course. Then after that, I feel you are ready to read some papers, state-of-art research. You will be able to understand what they are doing. And maybe you can even contribute, so you can push the frontier of research, help make the internet a safer place. So a little bit more about my software security class. So that class is about binary attack and binary defense. We use x86, which is the system, your laptop, your phone. No, your phone is not using x86 anymore. Your laptop, your desktop, most servers are still x86, which is an Intel CPU. We use that as an example, but the principle of that class apply to other computer systems, like Cortex-A, which is your phone. I believe everyone's phone is a Cortex-A. Has a Cortex-A CPU, is an ARM CPU. Then, so that course is about discover the vulnerabilities in the binary code. Most binary code are compiled from C++ programs. Then you need to identify the vulnerabilities. Then you exploit the vulnerability. You handwrite the exploit in that class. So there are some tools out there to automatically generate exploits, but in that class we handwrite exploit. We focus on memory corruption or memory safety problems, but we also touch at the microarchitecture level. We do stack-based buffer overflow. We talk about all the defenses in the last 15 years, maybe longer than that, 20 years. The defenses against the stack-based buffer overflow. You develop some share code. You learn how to exploit format string vulnerability, heap-based buffer overflow, return-oriented programming. We probably touch integer overflow a little bit, and many other topics. So, like I said, I have a platform I developed specifically for that course. So this is the URL for that one. Anyone at UB on UB campus, you can create an account and start playing there. You don't have to take my class to be there, and also all my materials are online anyway. If you are not on UB campus, you just need to VPN into that, then you can play software challenges there. So this class, we're going to use this textbook, Computer Security Principles and Practice. This is we use the 4th edition of this book. Each week, I will assign you several chapters to read. This book is easy to read. It's not like not technical. Okay, our materials in class, I would say, will be a little bit more in depth than this book covers. So we add a lot of materials are from other books, from our own experience. Like I said, I usually do not teach this course. The professor who usually teaches this course is on sabbatical this year. That's why I'm covering for that professor. So I'm trying to follow her style here, and this is a book she chose. There will be several homework, not many. In total, will only be 6 homework, and you will have enough time to finish all the homework. So there's no reason for you to cheat anyway. Also, we do take late submissions for homework. You got enough time. So if your submission is late for 1 day, there will be like 15% penalty. If it's I think there may be a typo here. If it's 48 hours later, actually after 24 hours, there will be 30% penalty. If it's late, it's 15. We don't take submissions after 48 hours. I will update that later. So all the homework, you have to do it individually. That's individual homework. There is no group homework. So last year I was not teaching this course, but I handled some AI issues. What happened in this course? Okay, so this is serious. So you are not allowed to search answers online. If you search some resources, not directly search the answers, you need to properly document where you find those resources, what do you take from those resources. And all the homework will be submitted on UB Learns. I will give, for each homework, I will give you a Word document. Then you can just type on the Word document, then submit the Word version or PDF version. So if plagiarism is found, then at least 0 point for that particular item, homework or exam, and that will be reported to the dean's office. And if it's getting more serious than that, then you may get a direct fail of this course. If you have a regrading request, you have to submit that to me within 2 weeks of releasing the grade. You should clearly say what happened, why the TA or the grader made a mistake. If you have if you need a DA, also let me know in the first 2 weeks. There will be 2 exams. The midterm is in-class midterm, so it's 1 hour 20 minutes. The final 3 hours, just 2 exams. So this is a breakdown of the grades. We'll have 6 homework, total 360. 2 exams, because the midterm is shorter than the final. But anyway, in total, there will be 630. Then every week, attendance check. Also, there will be 2 anonymous course evaluations. So if 90% of the class, 90% of the class submit the evaluations, and everyone gets 10 bullet points. There are 2 of those. So in total, we have 1K points, and then we have from A to F. Okay, any questions regarding the logistics? It will be a little bit different. Some of the homework, we will specify that clearly. So for undergraduate, you only need to answer those questions. Yeah. Anything else? Yeah. There will be some programming, for example, crypto, right? We will teach symmetric crypto. So you will learn how to use crypto libraries to encrypt and decrypt. There will be design questions for you to think. How do I design a secure system? Why the system we describe to you is not secure? Questions like that, yeah. There will be program. Doesn't really matter because this class is about the principle of computer security. I don't really care what language you use. Most likely will be C because Python will also be okay for some of the assignment because there are a lot of library available basically. Yeah. Cool. Then let's talk about some basic computer security concepts. So even if you took my software security course, I didn't really cover many of those security concepts in my class because I want to focus on battery. So basically cybersecurity is a problem no one can ignore right now. One of the reasons is computer is ubiquitous. Every one of you, right now you have several computers with you. Your smartwatch is a computer, your laptop, your phone. A lot of them have a screen, a lot of them do not have a screen. For example, your laptop has a main CPU, then there are many different other components. And each component may have their own CPU, and you can say they are an individual computer, so they communicate through some wired network. And cyber attack has been real. It's not like 30 years ago, some people with very good computer skills to show off their skill. Now cyber attack is really monetized. There is a huge business behind the cyber attack. And I just randomly picked 2 recent news. There was a hospital, I believe in Canada. It's called a Sick Children or Sick Kids Hospital. So their hospital was attacked by underground group by ransomware. So what ransomware does is to encrypt whatever is on your hard disk. So you do not have the access control of your own data. You don't have the access of your own data anymore. Then they threaten they will delete the data unless you pay a lot of ransom. Usually people ask several Bitcoin, much more than that actually right now. Depends on the scale of the attack. So I personally investigated something like that before. We investigated one of the early ransom attack. We were interested in how much money those criminals behind that attack made. So what we did is we collected many Bitcoin addresses which were found on those. So what ransomware do is ransomware will encrypt that. Then it will have a GUI show you, hey, you need to send money to this Bitcoin address, right? So we collected a lot of Bitcoin addresses like that. then we did a lot of analysis on the blockchain to try to figure out other Bitcoin addresses which are also associated with attack. Then we started for that particular case. We believe at least the criminals, they collected $500,000 worth Bitcoin that time. So you can say that kind of research is not very technical, but is still a very interesting jigsaw puzzle of the whole bigger picture if you want to understand security, the ecosystem security. Also, this morning there's a news coming out from, this is from BBC, that JD Sports, apparently that's a big company in UK, I guess. So they lost like 10 million customers' data, including credit card information, all of those information. So how many of you heard of something called the darknet? Yeah, many of you heard of darknet. So darknet is behind the Tor network, usually behind the Tor network. Tor is an anonymous network developed by the US government, some national, several national lab, I believe. So then behind the darknet, there are a lot of websites. There was a website which is called the darknet Amazon. You can buy all kinds of illegal services, illegal goods and services on that website. And we also crawled some data on those websites before, and we find that you can get a lot of credit card information, and you cannot believe how cheap your credit card information is there on those websites. Usually they sell 5,000 or 1,000 credit card information together for like $50, $100. Of course, they can sell that information to the many different people, right? So security is really a problem right now for everyone, not only individuals, not only big enterprise, but also government. So how do we define what is security? What is computer security? So NIST, they came up with this definition a long time ago. Maybe this has been more than 20 years, but still, this definition, we would say it's generic enough that it still makes sense today. So computer security they define is the measures and the controls that ensure the confidentiality, integrity, and the availability of information system assets. So the key here is, so first we define 3 security goals. One is confidentiality, another one is integrity, the third one is availability. So a lot of, no matter what layer of security you are working on, what domain of security you're doing, most likely you are working on those 3 problems. No matter you're doing software security or doing network security, they all fall into those 3 different goals. Then they also define some assets. They said including hardware, software, firmware, and information, right? So that basically covers everything. Everything right now can be asset. Side channel information can also be asset, right? So all of those should be protected, and sometimes must be protected. So the 3 main security goals are those that's called CIA, confidentiality, integrity, and availability. And also, many other researchers, they argue that there are other security properties which cannot cover by those 3. Most likely, people will say the other 2 will be authenticity and non-repudiation. But actually, many people will also argue those 2 properties or objects can also be covered by the first 3. So people have different opinions on this one. I will give you a little more details on each of them. First of all, confidentiality is about how do we prevent, detect, or deter improper disclosure of information or asset. So here, like I said, I use the 3 words: prevent, detect, or deter or even recover from. That is actually different stage of as a defender. That's a different stage. At a different stage, how do you protect your information, right? Before the information is disclosed, you want to prevent it from happening. But how do you know your information is not already being disclosed, right? So you need a mechanism to also to detect attack has already happened. The after attack happened, you need to think, how do I prevent this from happening in the future, and also how do I recover from this, right? So traditionally, we have the confidentiality of data. That is why encryption was very, very important. Like 50 years ago, security is all about data security. It's all about encryption. But then people realize encryption doesn't solve all the problems. But back then, data security, data confidentiality is the only important thing. Now, privacy plays a more important role. And privacy, it's very similar to data confidentiality, actually. Then the second property is, or second goal is integrity. This one is more and more important right now. So integrity is about how do you prevent, detect improper modification of your information. Maybe in this case, you don't care the information is disclosed. That can be public information. But the integrity of it will be very important. Some people can lie about something and say that is is your information, but it's not really, right? So then obviously data integrity is one of them, but a lot of integrity of other systems as well. For example, if you took my software security class, you know, one of the fundamental rule in software security is called control flow integrity, because program has different control flows. The one program is only one function is only supposed to call another function, and this function maybe can call several functions. But if at the runtime there is a control flow hijacking attack, there's a buffer overflow, then attacker can jump from one function to another function which the attacker is not supposed to call, and that doesn't break the confidentiality of the program, because the program may not have a confidentiality requirement in the first place. It doesn't break the integrity of the program. They didn't change the program. What actually it breaks is the integrity of the control flow in the runtime, right? So when you think about those concepts, do not confine yourself to just the data confidentiality, data integrity. Anything can be associated with those different goals. Availability obviously is just to make sure your system is available. That's why we have denial of service attacks. Denial of service attack do not really breach the data privacy or integrity. They just make the victim system unavailable. Denial of service. A little bit more examples, some simple examples about the CIA. For example, in this class, confidentiality. Everyone, you have the rights to know your own score, but you don't really have the rights to know your classmates' score, right? Only I know that, only the TA knows that. So if you breach the UB nurse and the NER, everyone else or someone's score, grade in this course, then you breach the confidentiality, right? And also, you should not be able to change or anyone else's score. So that is not confidentiality, that's integrity, right? So you get a B in the course, but you hacked UB nurse, you change that to A. So the integrity of the system is breached. Also, availability, your scores, your grades should always be available to you there on UB nurse. Someone may do a DOS attack, so UB nurse is not available to everyone. So everyone do not see their score, right? Authenticity usually means that we need to ensure a message, a transaction, basic action or some data is from the source it claims to be from. Using the same example here, let's say that you cannot or you should not pretend to be the TA or pretend to be me and send an email to your classmates, ask for the homework, right? So if you are able to do that, what you break is the authenticity of the message. The message you send out, you claim to be me, the TA, but actually you're not. So the example I gave you here is inspired by some real experience. So when I was a PhD student at Arizona State University, what happened in one of our software security course is some student registered a Gmail account using that professor's name and sent out a message to several other students and asked for, it's a software security course. So he asked for the exploits for the specific homework. So several students found that very fishy, then forwarded that to the professor, and then the professor needed to find out who is the guy behind this, right? So how do you do that? So several of you took software security course. So how do you do that? Okay, something like that, yeah. Yeah, similar idea. So what happens is, back then, the system the professor was using is different from the system we are using in my class. In my class, you log in first, so we can log all the actions you have. That time they have one server there. Then, if let's say this student logs in and just run the exploit and get the flag, no one can know how this exploit is different from other ones, everyone else exploit, right? So the professor sent this student, of course, through other students, send this student a particular exploit, and that exploit do not only get the flag, but also write who is running this exploit, get the username there to a hidden file. And obviously, the student, since he's asking for the exploit in the first place, he doesn't have the ability to check the exploit, right? So when he runs the exploit, then it leaves his user account there. Eventually, that student didn't get the degree there, right? So this is another example why you should not cheat in this kind of classes, in any kind of class. Yeah. Also, non-repudiation means no one can deny the message or transaction they send out or they performed. So blockchain actually solved a lot of related issues to non-repudiation. Because in cryptocurrency, one of the challenges in the early stage is how do you prevent double spending? It's digital asset. You can spend it multiple times at the same time, right? And then later you can. So how do we make sure you cannot do that? So those are related issues. So how do we achieve those objects? What kind of toolbox we have? What kind of measures? What kind of controls we design? So one of the most fundamental technique is crypto. There are all kinds of crypto tools, and we use them for different purposes. We customize them for different purposes. That's why the first topic we will cover in this class is crypto. We talk a little bit about how those crypto algorithms are designed, but this is not a crypto design class. Then there are different access control policies, access control mechanisms, also software checking tools. How do you find the vulnerabilities of a software before the software is delivered? Or how do you find software vulnerability if you are an attacker, right? So my research team, every year we play a CTF called the MITRE Embedded System CTF. So in that CTF, what we do is we design a secure system. Well, I mean, no system is really secure, right? That's why. So we design a secure system. Then we give the secure system to other teams who are also in this game. The other team will attack our system. We also attack other team's system. So this year, there are 80 teams in this game. So one of the challenges we have is, so previously what we do is we manually analyze other teams' code because code will be open sourced. We analyze their code manually, we find the vulnerabilities. But this year, when there are 80 teams, we only have like several people, then we know this is not doable. We need to design automatic tools to quickly find the vulnerabilities. So there has been a lot of research in this topic, how to automatically find software vulnerabilities, but most approaches are not specifically designed for the system we are using. We're using no-end Cortex-M systems. Most of those techniques were designed for applications running on your laptop, applications running on your phone. So there are still much different systems. Then virus scanners, you do not. So 10 years ago, virus scanners were still very popular. But because the last decades, we made a lot of progress in system security, you do not see as many malwares as before, to be honest. 10 years ago, malware was terrible. But now, if you use many people using Mac or Linux, they do not even have an antivirus running there, right? And Windows have their own antivirus software. There were not so many antivirus companies anymore. That's because defenders made a huge progress in the last 15 years. Firewall is also a system to isolate different network entities. So all of this we will touch in this class. In general, security is still a very, very difficult problem, very hard to solve for many reasons. First of all, even identifying the security needs of a system is very difficult. Everyone has a phone, everyone has a laptop. What do you think is your security needs of your laptop? You have a password, but does a password solve all the problems? No, right? Your hard disk is encrypted right now. Most of you, your laptop, your hard disk is encrypted now. But does that solve the problem? What if someone physically take your laptop and take out the main memory, put that memory on a different laptop and dump the information there, right? So that is called a cold boot attack. Some people will freeze your memory and prove that you can still dump the content after several hours. So in one of the eCTF we performed, we actually did the same thing. We did in that year, we were supposed to develop a secure gaming system, kind of like an Xbox. And one of the goals is the confidentiality of the games. So the games were loaded in an SD card. And of course, every team will encrypt the game on SD card. But when the game is loaded in the memory, the game is an application, right? When the game has to run, it has to be decrypted. So when we decrypt that, it's plain text in memory. Then technically, there is a window. After it's decrypted, then if we can dump the content in the memory, we can breach the confidentiality, right? So several teams did that. We were one of the teams. I believe 3 teams figured out how to do that. We were one of the teams. So that year we got the 3rd place. So then people will think, then what is the next step? How do we protect the confidentiality of the data in the memory at runtime, right? That's why in recent years, most companies, several chip companies come up with a new idea called Trusted Execution Environment, TEE. Intel has a technology called SGX. Memory is encrypted. ARM also has TrustZone, but TrustZone doesn't really encrypt memory. So we do a lot of research on trust zone as well. Why security is hard? Also, even if you identify the needs, come up with a smart solution is really hard. The solution needs to consider known attacks and also a lot of unknown attacks. In software security, we have the concept called zero-day vulnerability. Means the attacker finds out there is a bug, but this bug has not been disclosed publicly. People on internet do not really know this bug exists. So the bug obviously has not been fixed. The attacker can attack all the systems, and only many days later, the bug will be patched. Also, securing system is not a one-time task because the attackers, they evolve. So our defense also need to evolve. So for those who took my software security class, when you do buffer overflow, you feel, oh, this is already some very interesting attack. But then people figure out how we can stop buffer overflow. Then seems like it's very difficult to attack. Then all of a sudden, someone find out we can do return-oriented programming. We do not need to inject the share code. Then a whole new world was found there, right? And also because of the other aspects of the whole ecosystem. First of all, most companies, they haven't realized how important security is. Or let's put it another way, the cost of security is still too high for them. They have no reason to accept that high level of cost until something really bad happens, right? Also, users, they view security as an obstacle. That's why many people still choose very weak passwords. Even typing non-passwords is troublesome for most people. And we also need to, the cost has many different aspects. It could be performance cost, it could be the money budget, those kind of different things. And a lot of systems, when they were designed, they do not have security design in the very beginning. That's why now people are arguing when we design anything, we should have security at the beginning. Security should be an integral part of the design, not an add-on later. So the takeaway here is security is not absolute, which is a good thing and also a bad thing. If security is absolute, if one day we can really achieve absolute security, then this class will not exist anymore, right? I probably will lose my job also. Also, we think about, there are many people, you probably read a lot of news talking about quantum computer maybe bring you absolute security, right? Many people may read something like that. But do you really believe that? We already have a lot of systems. In theory, they are perfect. Or at least in theory, we cannot prove it has problems. Like, for example, RSA, right? This is a crypto system we've been using. RSA, the security of RSA eventually is about whether P equals NP, right? No one can prove that, and no one can disprove that. Anyway, but so let's say RSA so far, the crypto is still very solid. We can say it's perfect. But it doesn't mean the implementation of that is also bug-free. Even though the design is perfect, the implementation may have a lot of issues. So one of the example is a vulnerability called Heartbleed. Anyone remember that? Heartbleed? Yeah? What? No. Heartbleed is not about CPU. Yeah. Heartbleed is about the TLS. So So TLS is a protocol to secure your online web surfing experience. Everyone right now, you have a browser, right? You have a lot of tabs there. So your browser is talking to a remote server, and that communication is secured using a protocol called TLS. And TLS will use different crypto algorithms to encrypt the message. So what happens is, let's say no one can break the crypto. Let's assume no one can break the crypto. But if you just leave the key for that particular crypto algorithm in your memory for someone to get, then the whole system is not secure, right? So Heartbleed is a vulnerability. It's just a buffer overread vulnerability in the most popular implementation of TLS. So basically, one side of the communication party can talk to, let's say, you are the user. You use a browser. You talk to the server, and the server has the crypto keys in its memory. The bug is you can send out a message to the server and ask the server to do an echo. That's why the original part of that protocol is called the heartbeat. Heartbeat. Yeah, basically it's an echo service. So for the server and the browser to load, the other end is still online, right? But when you send out a message to the server, you can tell the server how long is the message I'm sending to you. You may only send a hello, 4 bytes, but you tell the server, I'm sending you 2,000 bytes, and you need to give me back 2,000 bytes. So what the server does is the server will give you the 5 bytes, hello, then 1,195 bytes after that. Okay? So it's a buffer overread vulnerability. And because of that, in that 2,000 bytes, there may be some sensitive information. The key for this encryption, or even for other sessions encryption. So you can search that. It's called Heartbleed. So in this case, the crypto design is perfect. Okay, you can even use quantum encryption to replace RSA to make it more secure. But the implementation of that has some issues, which has nothing to do with the design of the crypto itself, right? So that's why when everyone argue, when you go to the job market or when you purchase some security service, you will always say someone argue, my system is unbreakable. My security is absolute, right? So when you say something like that, you probably should think this is very likely to be a scam, okay? So security is not absolute. There is always a trade-off between security and the resources. For the systems I work on, those no-end devices, it usually means there is, but for most of the system guys or security guys, it most means there is a trade-off between security and performance. If you add more security features, your system inevitably will be slower. There are some other concepts the book covers. I will just go through some of the concepts here. Security policy, basically rules of practice that specify how a system organization is prescribed to protect its asset. Vulnerability, this for those who took my software class already know what a vulnerability is. It's a flaw, a weakness in the system's design, implementation, or operation that could be exploited to violate some security goals, violate some security policies. Threat is a potential for violation of security. Attack is, well, everyone knows what is attack. Then there is attacker or adversary. That's an entity that attacks a system. Obviously, there are many different attackers in the world. There are script kiddies who just use existing tools. There are advanced attackers who develop tools. There are nation states use cybersecurity as a weapon to attack other countries. A countermeasure is an action, the measure, the controls that reduce a threat of vulnerability. And a risk is an expectation that a particular threat will exploit a particular vulnerability. So those are the concepts we will use throughout the semester. There is actually another concept I think the book didn't talk about, is trust. So trust is in the core of security, especially for the good guys, for the defenders. Everything you build is built on top of some kind of trust. Okay, you, for example, let's go back to that password example. You use the browser's password manager. You only need to remember one password. You don't have to remember multiple passwords. Of course, before that, everyone just reuse password for different websites, which is extremely unsecure. I actually have a paper on that. It's talking about how do you just change password a little bit. Everyone just change their password a little bit. Yeah. So, but when you think about that, you use your browser's password manager to store all your password, which implies that you trust your password manager. You trust the browser, right? Most of you, I use Chrome. It means I have to trust Google. So actually, when you think about this, you have to trust a huge organization behind this. Not only trust the integrity of the organization, you also need to trust their ability. You trust the Chrome they develop is secure, right? People cannot break Chrome. There is a software availability of Chrome, so people can steal my password. So trust is at the heart of all kinds of defense mechanisms. So one of the goals in security design is to minimize this trust. We call it the trusted computing base. How can we make the trusted computing base as small as possible? Okay, so that is one of the research areas. Like in crypto, like in, let's say we use symmetric crypto as example. You have keys, you have a crypto algorithm, you have crypto encryption. The crypto algorithm, we just make it public. The crypto implementation of this is public as well. So the only thing you need to trust is the key. You need to trust the key will not be disclosed. You don't need to trust the code of your crypto is not disclosed because it's public anyway. So when you design a crypto algorithm, that's a fundamental principle. You do not hide your crypto design. You make your crypto design public. That's very counterintuitive. A lot of people, when they think about design a secure system, they think, I need to hide my system from other people, right? Like in our eCTF, embedded system CTF, we design a secure system, then we open source it, give our system to other people to hack. We do not hide it from other people. We do not only give them binary, we give them source code, right? So that's another core concept, which is not covered in the book, I believe. Going back to adversaries, there are many different types of adversaries. There are passive ones, active ones, especially in network security. You will say those concepts come up a lot. A passive attacker, basically, they only observe information. They do not actively send out messages. Then an active attacker will actively alter the system, will actively send out messages. There are also insiders and outsiders. And it used to be like a big organization, a big enterprise. There are people outside, we call them outsiders. Then there are people work for the organization, we call them insiders. And all previously, like, I don't know, 10 years ago, people were mainly care about the outsider attacks. But now we see more and more insider attacks. Some people inside the organization were compromised. They breached the confidentiality, integrity of data there. So insider threat is also is getting more attention right now. That's why recently, in the last 5 years, there's a new concept coming from industry. It's called zero trust model. Anyone heard about zero trust? Yeah. So, but going back to the trust issue, zero trust, the term doesn't make sense, right? Because you have to trust something to bootstrap your trust for everything. So zero trust doesn't make sense. But the term doesn't make sense. But the concept is actually about how to make the TCP smaller and smaller. The TCP here doesn't only include the machines, but also human. Okay, I think this is my last slide for today. So Wednesday, we will dive into symmetric crypto. The last one is about security design principles. All of you are programmers, okay? No matter you will be a security guy or not, you are in computer science, you will be a programmer, or at least you program. So when you program, you need to think about security. You should think about security. And when you think about security, you should think about those principles. One of the first principles I will emphasize will be fail-safe default principle. So all of you write an if statement, a switch statement. And your if statement, switch statement, there is always the last case, which, well, if we do a random fuzzing, most example will go to the last case. But if the last case is really a safe case from security point of view, another one I would say is isolation, encapsulation, especially isolation. For system security guys, what we're always trying to do is to do isolation. At the very beginning stage of computer, there is no isolation. There could be multi-programming. Several different people, they will use the same computer, but their programs were not isolated to each other. One program has a bug, it can crash someone else's program, right? Then we bring multi-programming, so each one's program were somehow isolated. Then we isolated the kernel and applications. Now we have even higher degree of isolation. We can, on one top of one CPU, we can run multiple virtual machines. In one virtual machine, we have many different processes. Then in each process, there are different threads. Somehow they could be isolated. That could, people in my class, one of the most successful mechanism for defeating buffer overflow is still stack cookies, stack calories. That's a super simple mechanism, but it's almost free. Performance-wise, it's almost free. That's why it's so successful. There are more advanced techniques, but they are not used in real world solutions. Another one I want to mention here is separation of privilege or least privilege. This is also related to isolation. Very important design principle. When we design the operating system, we design the system into different layers. There's an operating system layer, there's an application layer. The operating system will talk with us hardware. The application do not talk with the hardware directly. If the application talks with the hardware, the application are bug, it will crash the system. But which means the application doesn't really